Hello, hi everyone. Welcome to the class. So myself, I'm Shiva sir. Today we are going to discuss about light reflection and diffraction. So actually, electricity problems we are discussing. Electricity problems are discussing. So though still it's going on. Still it is going on. So we'll do it. So we'll give some gap for electricity. Now we'll work out on light reflection and diffraction. Light reflection and diffraction. So very important topics, very essential topic. We have to work out. Okay. So in the exam, so the based on this one, we need to discuss first related to light reflection and diffraction. Related to light reflection and diffraction. So now we are working on it. So welcome to the class. So welcome to the brand of physics, student the brand. So we are going to the light reflection and diffraction chapter. Especially topic, so we'll try to do it topic with problems if it is possible. Maximum will work out on it. So it's a small song. With a small song, we'll start with the light reflection and diffraction chapter. New Cartesian, new Cartesian, new Cartesian sign convention, new Cartesian, new Cartesian, new Cartesian sign convention. New Cartesian, new Cartesian sign convention. All the distance measure from the pole. Distance positive. Distance positive. Along the instant race. Distance positive along the instant race. Distance negative opposite to instant race. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance positive along the instant race. Distance negative opposite to instant race. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian, new Cartesian, new Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Distance positive along the instances. Distance negative opposite to instant race. Distance positive above the principal axis. distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive above the principal axis. Distance are negative below the principal axis. Distance are positive along the instant trace. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. La 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 la. La 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 la. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance are positive along the instant trace. Distance are negative opposite to instant trace. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance are measured from the pole. Distance are positive above the principal axis. Distance are negative below the principal axis. Distance are positive along the principal axis. Distance are negative opposite to instant trace. Okay, so that is about New Cartesian sign convention. So New Cartesian sign convention song. Now we are going to the light reflection and refraction chapter. I hope you are aware of it. So that is about you can see the title. You can see the title. So very, very important. Now I am considering so light reflection and refraction, CBSE grade 10 physics. Light reflection and refraction. Light reflection and refraction. Light reflection and refraction. CBSE grade 10 physics. CBSE grade 10 physics. So CBSE grade 10 physics. So now you can see light is a form of energy. Light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. When light falls on it, so it will reflect back. It reflect back. So you can see. So I'm taking the plane surface. This is the plane surface. I'm taking the coating here. So incident. This is the plane surface. A highly polished smooth surface. Plane mirror. A highly polished smooth surface is called plane mirror. A highly polished smooth surface is called plane mirror. A highly polished smooth surface is called plane mirror. A highly polished smooth surface is called plane mirror. The light which is incidenting on it, so I'm taking this the incident ray. The light which is incidenting on it, that is incident ray. The light which is reflecting back, the light rays which is reflecting back, so that is a reflected ray. The light ray which is reflecting back, so incident ray, reflected ray, reflected ray, reflected, so the line which is perpendicular to the plane surface, that is a normal. This is the normal. I am taking the normal line. So plane mirror, so incident ray, reflected ray, normal line. So angle between incident ray and normal line is called angle of incidence. Angle between reflected ray and normal line is called, so angle between reflected and normal line is called, so angle of reflection. So we are drawing this one. We are drawing this one. Undeviated line. The angle between reflected and deviated line is called angle of deviation. Angle of deviation. Once again, angle of deviation. So now you can consider. Now you can consider. Now you can consider. So now we can consider. So when the light ray is incidenting on it, so that is incident ray. The light ray which is incidenting on it, that is incident ray. The light ray which is reflecting back, that is called reflected ray. The line which is perpendicular to the surface, that is called normal line. The angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between incident and normal line is called angle of incident. Angle between reflected and normal line is called angle of reflection. Angle between reflected and deviated line is called angle of deviation. Angle of deviation. Angle of deviation. Angle of deviation. Okay, so now we are considering, so actually linear angle. So a highly polished smooth surface. A highly polished smooth surface is called plane mirror. A highly polished smooth surface is called plane mirror. Highly polished smooth surface is called plane mirror. Linear angle you are taking. What is a linear angle? So how much? 180 degrees. So in that, so if you are taking, is if you are considering angle of incident, so angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So we are loss of reflection. So can I know the loss of? I mean, it's cool. I like the way you teach, sir. Thank you so much. So here you can consider loss of reflection, 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 loss of reflection. So first one, angle of incidence equal to angle of reflection. Second one, angle of incident is equal to angle of reflection. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Lies on the same plane. Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection. Angle of incidence is equal to angle of reflection. Angle of incident equal to angle of reflection. Angle of reflection. First law of reflection, that is the angle of incident equal to angle of. So incident ray, reflected ray, normal line lies on the same plane. It would be great if I was studying 10th, so I could study all this from, yeah. Oh my God, excellent. Thank you so much. Definitely I'll teach. So we'll go with that. So incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane, lies on the same plane, lies on the same plane, lies on the same plane. Angle of incidence is equal to angle of reflection. Angle of incident is equal to angle of reflection. So there are two laws of reflection. What are those? Angle of incident equal to angle of reflection. Incident ray, reflected ray, incident ray, reflected ray, normal line lies on the same plane, 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 lies on the same plane. Yes. So now you are considering, so according to the laws of reflection, according to the laws of reflection, according to the laws of reflection, angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees, 180 degrees. So now you are seeing here, angle of incident in the place of angle of reflection, I am substituting angle of incident. So 2 angle of incidence plus angle of deviation equal to 180 degrees. 180 degrees angle of deviation equal to 180 minus 2 angle of incidence. Angle of deviation equal to angle of deviation equal to angle of deviation equal to angle of deviation equal to, listen everyone, I am telling to you only, angle of deviation equal to 180 minus 2 angle of incidence, angle of deviation equal to angle of deviation equal to angle of deviation equal to angle of 180 minus 2 angle of incidence. We can also take angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. Angle of deviation equal to 180 minus 2 angle of reflection. Angle of deviation equal to, doesn't really know that much in this, so I recommended typing in English. Thank you so much. Thank you for all. So angle of deviation equal to 180 minus 2 angle of incidence. So angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of reflection. So are you listening everyone? Angle of deviation equal to 180 minus 2 angle of incidence. So we can also write the same formula. Angle of deviation equal to 180 minus and 180 minus 2 into angle of reflection. So the formula is here. I given here angle of deviation equal to 180 minus 2 angle of incident. Angle of deviation equal to 180 minus 2 angle of reflection. So hi everyone. So welcome to the class. Okay, so now we are going to the next one. So that is, I hope you got it. So angle of loss of reflection, 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 angle of incidence equal to angle of reflection, incident ray, reflected ray, normal line, incident ray, reflected ray, normal line, lies on the same plane, lies on the same plane, lies on the same plane, lies on the same plane. So hi everyone. So okay, great. So all the best, Shivani. So do well. So hoping for the best. Nisha, apparent distance, so sorry for that, but I can't able to understand complete Hindi. So thoda understand aata. So please type in English. That's my request. So coming to the last regular reflection, regular reflection, regular reflection, regular reflection, regular reflection, regular reflection, regular reflection. We are taking the plane mirror here. Light rays incident, parallel light rays incident on the surface. Do you know regular reflection? Do you know regular reflection? What exactly is happening? What exactly is happening? What exactly is happening is asking for apparent distance formula. Apparent distance. Where? Mirror or glass slab? In glass slabs, so different. So mirrors, it depends. So object distance is equal to image distance here. Okay, then. So loss of reflection, loss of reflection, loss of reflection completed. Next, regular reflection. What is regular reflection? Are you understanding regular reflection? When the incident light rays are falls on it, when the incident light rays falls on it, when the incident light rays falls on reflected light rays also parallel to each other. If the incident light rays are parallel, reflected light rays also parallel, that type of reflection is called regular reflection, regular reflection, regular reflection, regular reflection. So if you are taking the incident rays like this, incident ray, reflected rays like this, so these are the incident beam, incident parallel beam, incident beam, incident beam. So this is the reflected beam, reflected beam. reflected beam, reflected beam, reflected beam. So incident beam is parallel, incident beam is parallel, reflected beam also parallel. Incident beam is parallel, reflected beam also parallel. Incident beam is parallel, reflected beam also parallel. This type of reflection is called regular reflection, regular reflection, regular reflection. Are you understanding or what? Regular reflection. Okay, then come to the next one. Come to the next one. Irregular reflection, irregular reflection, irregular reflection, irregular reflection. Tan 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 tan. Irregular reflection. Come on. Irregular reflection, irregular reflection. If you know that reflection comes when incident light tracer falls, when incident light tracer falling on it, incident light trace, when incident light tracer falls on it, when incident light tracer falls on it. So I'm taking here, these are the plane surface, so these are the irregular surface. So this is the irregular surface, this is the irregular surface, this is the irregular surface. Incident beam, these are the incident beam, these are the incident beam, these are the incident beam. Incident beam, when the incident beam is falling on the surface, incident beam is falling on the surface, reflected light rays are not parallel to each other, reflected light rays are not parallel to each other, reflected light rays are not parallel to each other. That type of reflection is called irregular reflection. Light rays are not parallel to each other, light rays are not parallel to each other, light rays are not parallel to each other. This type of reflection is called irregular reflection, irregular reflection. So surface is rough surface, soft surface is rough surface. Remember, irregular reflection takes place on rough surface, regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Irregular reflection takes place on rough surface. Rough surface. Example for regular reflection: plain mirror and still water. Example for irregular reflection: we can take wall, book. So anything we can take. It's okay, it's fine. So normal only. Okay, come to the point. So this is about regular reflection, irregular reflection. So everyone listen here. Everyone listen here. I'm saying here. My name is Siva sir. My channel name is Student the Brand. My name is Siva sir. My Student the Brand channel name here. When the incident beam is parallel, reflected beam also parallel. This type of reflection is called regular reflection. This type of reflection is called regular reflection. Incident beam is parallel, but reflected light rays are not parallel to each other. Reflected light rays are not parallel to each other. This type of reflection is called this type of reflection is called this type of reflection is called irregular reflection. Irregular reflection, irregular reflection. Listen everyone, very very important. Learn this question I am saying to you. Very 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 important. Come on. So now I am considering. So very, very, very important, very, very important, very, very important. So if you are taking before coming to any important topic, so we need background music. Yes or no? We need background music. We need rhythm. If you are reading any important concept, we need background music. We need extraordinary music. We need BGM. Our BGM is dun 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 dun. Come on, next topic is very, very important. Very, very important. Very, very important. Come on, be ready, everyone. Be ready, everyone. Be ready, everyone. Be ready, everyone. Come on, come on, come on, come on. Come on. Yes, yes, yes. The topic is object and image. The topic is object and image. I'm taking the plane mirror here. I'm taking the plane mirror. So I'm considering the principal axis. I am taking the object here. Object. This is the object. This is the object. This is the object. Object. How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Minimum 2 light rays or not? Minimum 2 light rays or not? Yes, minimum 2 light rays are required to form the image of the object. I am taking 2 light rays. Come on. 2 light rays. Come on. How many light rays? 2 light rays. How many? How many light rays are required to form the image of the object? How many light rays are required to form the image of the object? Come on, tell me. Come on, tell me, everyone. Minimum 2 light rays are required. Yes or no? Minimum 2 light rays are required. So I am taking 2 light rays. First light ray I am taking here. This is one light ray, and one more light ray I am taking here. One more light ray. Come on, come on. So I am taking object is here. So one light ray I am taking here. This is one light ray. This is one light ray. Come on, you observe here. Do you observing or not? Do you observing or not? Yes or no? Do you observing or not? Do you observing or not? Yes, here. So this is the incident ray. This is the incident ray. Come on. This is the incident ray. This is the incident ray. How many light rays are required to form the image of the object? Minimum 2 light rays or not? Minimum 2 light rays or not? Yes or no? Tell me yes or no. Minimum 2 light rays are required to form the image of the object. Now you are seeing here, one light ray I am taking, it will be reflected back. Another light ray I am taking, this reflected back. So if you are extending those light rays, those light rays will meet at one point. So the image will form here. The image will form here. So these are the reflector light rays. Yes or no? These are the reflector light rays. Reflector, we are extending these reflector light rays. Their image will form. Their image will form. What is the type of image? What is the type of image? What is the type of image? Virtual image. Come on, virtual image. That type of image is called virtual image. Virtual image. This is the real object. Real object. From this point, so light rays are coming from that point. Yes or no? Light rays are coming from one point. Light rays are coming from one point. Light rays are coming from one point. If the light rays are coming from one point, so those light rays will be reflected. The light rays are incidentting at one point. Those light rays are incidenting on the plane mirror. Those light rays are incidenting on the plane mirror. Those light rays will be reflected back. Those light rays will be reflected back. Those light rays are reflected back. After that, we are extending those light rays. After that, we are extending those light rays. Their image will form. That is virtual image. Come on, focus. This is the virtual image. Come on, understand? Yes or no? Virtual image or not? So listen carefully. Once again I am explaining. So incident ray. So this is the object. So mirror. This is a mirror, object, real object. So like I'm taking the candle. I'm taking the candle. One candle I'm taking. Yes or no? So object I'm taking. Object I'm considering. This is the object. From that object, light rays are coming. How many light rays are taking? Why I'm taking 2 light rays only? The minimum light rays are required to form the image of the object. How many light rays are required to form the image of the object? Minimum 2 light rays. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. How many light rays? Come on, tell me. Minimum 2 light rays are required to form the image of the object. So I am taking 2 light rays here. So after incidenting, those light rays are reflected back. After incidenting, reflected back. So you can understand here. You can understand one thing. Where you can understand one thing. So these reflector light rays are meeting at one point. So those dotted lines represent. We are extending those light rays. Those dotted lines are representing. We are extending those light rays. Those dotted lines represent. We are extending those light rays. Their image will form. What type of image is? Virtual image. Come on, virtual image. What type of image? Virtual image. So focus. So I'm taking 2 light rays here, 2 light rays here. This is the object. From the object, 2 light rays are coming. After incidentating, this was the reflected back. Those reflector light rays are meeting at one point. Their image will form. What type of image will form? Virtual image. What type of image will form? Virtual image. Come on. If the reflector light rays are meeting at one point, is known as virtual image. The point of intersection of Extended reflected light rays. Now I am telling the definition. Listen carefully. The point of intersection of reflected light rays. The point of intersection of extended reflected light rays. The point of intersection of extended reflected light rays. The point of intersection of extended reflected light rays. The point of intersection of 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 extended reflected light rays is called virtual image. What is a virtual image? The point of intersection of extended reflected light rays is called virtual image. Okay, is it any possible? Is there any possible we will get? Is there any possible we will get virtual object? Yes, yes, we can. So I'll show you how to do it. So I am taking, are you listening or not? I am taking the mirror. This is the mirror. Mirror. So principal axis, I am taking the principal axis here. So the light rays are coming from certain points. I am taking light rays like this. Light rays are coming from the object. After reflection, light rays are meeting at one point. After reflection, so these are the light rays. Incident light ray, incident I1, I2. So this is R1, R2, I1, I2, R1, R2. Come on. This we are extending those light rays. These we are extending those light rays. Those light rays are meeting at one point. So this is reflected. This is what incident ray. 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 You are extending those incident ray. Come on, focus. Focus on this point. Focus on this point. You can focus. Come on. If you focus here, you can see. So incident ray. So after reflection, those light rays will meet at one point. After reflection, those light rays will meet at one point. Their image will form. That is real image. Come on. That is real image. We are extending. Come on, you can observe here. We are extending this incident light rays. Those incident light rays are meeting at one point. Their image will form. That is the virtual object. Yes. By this we can conclude that one point. That is you can understand one thing. That is, if the object is very important, very important, object and image. Object is real, image is virtual. Object is virtual, image is real. Are you understanding or not? Focus on this table. Focus on these 2 points. Focus on these 2 points. Very important. Very important. How it is? So you see, these are the incident light rays. These are the light rays are coming from the object. After reflection, we are extending those reflector light rays. This is the incident ray I1, I2, reflected ray R1, R2. So those reflector light rays are meeting at one point. Their virtual image will form. So here virtual image, here real image. What is the difference? We are extending the reflector light rays. Here directly reflector light rays are meeting. Are you understanding or not? Are you focusing or not? Here we are extending the reflector light rays. Here directly reflector light rays are meeting. So here we are extending the reflector light rays. Here we are directly reflector light rays are meeting. So that is a virtual image. This is a real image. So virtual or real object, from the object light rays are coming. So this incident light rays, we are extending this incident light rays. Those incident light rays are meeting at one point. Their virtual image, virtual object. Yes or no? Virtual object. Come on, this is very important concept. Very important concept. You need to understand one thing. If the object is real, image is virtual. Image is real, Object is virtual, object is real, image is virtual, object is real, image is virtual, object is virtual, image is real, object is virtual, image is real, object is virtual, image is real, image is virtual, object is real. Now you are understanding or now you are understanding or not. So one thing, the point is, object is real, image is virtual, object is virtual, image is real. That's enough. Very simple, very simple, very simple. Easy concept, easy concept. Object is real, image is virtual, object is virtual, image is real. So we are taking vice versa, that's enough. Simple thing, easy thing. So very simple one. If the object is real, image is virtual. So here you can observe a concept. Object is real, image is virtual. Image is real, object is virtual. That only I wrote. Object is real, image is virtual. Object is virtual, image is real. That's enough. That's enough. Very good concept, right? Yes. Definitely. So object is real, image is virtual. Object is real, image is virtual. Image is virtual, object is real. Image is virtual, object is real. Come on, very important concept. That's why I'm stressing it. Next, we are going to discuss this one. This is a part 1. Next, we are going to discuss about part 2. Part 2, it is extension of this one. That's enough. Extension of this one. So now you can see. I'm explaining next one. Come on. Ready? Be ready. Take pen and book. Be ready for the war. Come on. Very simple. Very simple. Very simple. So now, image formed. I'm taking the plane mirror here. So I'm considering. So this is the object. So object height. So size of the object. So A here and B here. Object height. So I said, how many light rays are required to form the image of the object? Yes, continuation. Still it is going on. Now I am working on plane mirror. Next spherical mirror. Next convex. Next lens. So complete topic. So we are going to discuss. So we'll see. Now you are understanding or what? Are you understanding now? Yes or no? Plane mirror. Now we are discussing the plane mirror. Yes. So here I'm taking the object here. Object height is AB. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. Very good. Now I am taking one light ray here. So here normally if you are taking the plane mirror, when the incident light rays are falls on it, it will reflect back into the same direction. When light ray incident on it, it reflect back into the same direction. It traces its original path. Incidenting, reflecting in the same direction. 1, 2. Very nice. So I'm taking here like this also. Okay. So one more light ray I'm taking here. So this is incident ray. This will be reflected like a reflection phenomena. So I'm taking the normal here. And along this one also incident ray, reflected ray. So and one more light ray I'm taking here. Incident ray, reflected ray. So this is normal. So here, what type of image will form now we will see. So I'm extending this light ray. Actually, if you are extending, we can extend, right? We can extend the reflector light ray. So we are extending reflector light ray. Yes or no? Yes or no? So we are extending reflector light ray, and we are extending this one also, Here, if you are taking here, image will form here. What type of image will form? Virtual image. So this is the object. So one light ray I am taking. So along the normal line it passed. If it is incidenting, so if it is if you are extending the reflector light ray, so here it will meet. and this is the reflected ray, so it will reflect. Incident ray, reflected ray, so you're extending the reflected light ray. So here also reflected light ray, here also reflected light ray. So their image will form. What type of image will form? Virtual image. 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 Virtual image. Virtual image. Now you are considering point number 1, object. So here, if the object is real, as I said the previous concept, I said right. Object is real, image is virtual. Object is real, image is virtual. Object is virtual, image is real. Yes or no? So here also same thing. Object is real, image is virtual. Object is virtual, image is real. So vice versa. Second point is object distance is equal to image distance. Object distance. See, the distance between object to mirror is called object distance. The distance between image to mirror. Image to mirror. So first one, object distance is equal to image distance. Second one, height of the object equal to height of the image. Only in plane mirror, only in plane mirror. So height of the object equal to height of the image. So third one will get magnification +1. That is nothing but height of the image equal to height of the object. Magnification is +1. Only in plane mirror. Only in plane mirror that you will get magnification +1. Magnification +1. Magnification +1. Object distance is equal to image distance. Height of the object is equal to height of the image. Height of the object equal to height of the image. Magnification is +1. So object distance is equal to image distance. And the next one you are going to the, it also shows lateral inversion. So what is the lateral inversion? Lateral inversion is nothing but the phenomena of converting of right side of the object appears to be left side of the object appears to be right side. So right side of the object appears to be left side of the object appears to be right side. Right side object appears in the left side of the image. Left side of the object appears to be right side of the image. This phenomena is called lateral inversion. So the phenomena of converting of right side of the object appears to be left side of the object appears to be right side. If you stand in front of the mirror, if you lift your right hand, it appears in the left side. If you lift in the left hand, so it appears in the right side. So hi everyone, those are saying hello. So JMRH TV, hello, and Salmat, hi, and Saili, hi, Saili, okay. So everyone, hi, those are saying very hi to me. So hi everyone, welcome to the class Student the Brand. So myself Siva sir. So my channel name is Student the Brand. If you like this content, do like, share and subscribe to Student the Brand. Inform your friends. Notion, hi. So wonder science, yes, it is physics. I am physics teacher Siva sir. So my channel name is Student the Brand. Yes or no? Student the brand. Okay, come to the point. So we are going to the next one. Object distance is equal to image distance. Height of the object equal to height of the image. It also shows lateral inversion, plane mirror. So lateral inversion is nothing but 10th class. So grade 10 physics, CBSE. So here you can see. So light reflection, refraction, CBSE grade 10 physics. Yeah, of course, physics only. Okay, done. Come to the next one. Next one. Come on. Yes, always Student the Brand. On fire. Okay, done. So now we are going to the next one. So mirrors. Spherical mirror. Are you spherical mirror? The mirror is in the part of the mirror which is in the form of curved surface. The mirror which is in the form of curved surface is called spherical mirror. The mirror which is in the form of curved surface, that is called spherical mirror. spherical mirror. Spherical mirror. Yeah, thank you so much for supporting. So I'm very happy to see you all in the class and supporting the class. Thank you so much. So now we are going to the spherical mirror. Spherical mirror, spherical mirror. So spherical mirror, spherical mirror. Okay. So normally you are taking the sphere. So normally I'm taking the circle. So if you take small portion, that is called curvature. That is curvature. 11th grade. I am also 11th grade. I will support, sir. Thank you so much. Okay. So what is it, Victor? Thank you so much. So the mirror which is in the form of curved surface, that is called spherical mirror. So here I'm taking Anurag. Hi, and sir, but please take care of your health. So I am thank you so much for that. I'm also teacher. Okay, done. Anurag. Okay. So that's enough. Come to the point. Now I'm going to the discussion. So I'm going to the next topic, spherical mirror. Spherical mirror, the mirror which is in the form of curved surface. If the reflection takes place inward, that is called concave mirror. Concave mirror. Reflection takes place inward. That is known as concave mirror. Convex mirror, reflection takes place outward. Convex mirror, reflection takes place. So reflection takes place outward on convex mirror. This is a convex mirror. This is a concave mirror. Convex mirror. Concave mirror. Concave mirror. Reflection takes place inward. That is called concave mirror. Reflection takes place outward. That is known as convex mirror. Do you know one thing? Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Why you are saying like this? Sir, why you are saying like this, sir? Sir, why you are saying like this, sir? Concave mirror is known as converging mirror and convex mirror is called diverging mirror. Sir, how you are saying, sir? Please tell me, sir, why you are saying like that? So when light racer falls on it, it reflects back. Those light rays will move towards the principal axis. If the light rays incident on it, those light rays reflect and moves towards the principal axis. That's why it is called converging mirror. Whenever light rays incident on it, after reflection, those light rays will move towards the principal axis. That's why it is called converging mirror. Suppose you are in home in early morning when college or school start. Immediately you'll go to college or school from homes. So you are moving towards college. That is called converging. After college or school, you are going to home. That is diverging. You are moving from that point. Here also same thing. After reflection, those light rays will meet. Those light rays will move towards the principal axis. After reflection towards the principal axis, that's why it is called converging mirror. So it is diverging mirror. After reflection, those light rays will move away from the principal axis. This one is called converging mirror. This one is called diverging mirror. Example for converging. So example for converging. Example. So we are talking about converging or diverging. That's why I'm explaining. If the light rays are converging towards the principal axis, so we are talking about related to principal axis. So related to principal axis, after incidenting, the light rays will move towards the principal axis. So that's why it is converging. Anyway, any surface in. So there are two things will happen. One is so after incidenting on the plane mirror any surface, so either absorption of some of the light will be absorbed, some of the light will be reflected, some of the light will pass through. If it is a transparent medium, completely it allow. So those things will happen. But I am talking about only how the light ray, how the phenomena, how it is converging. So how it is moving. Based on that one, whether it is converging or diverging. So I am talking, sir. So that's enough. I'm talking about only whether it is converging or diverging. So I'm focusing on only that point. So that's why whenever the light rays incident on it, it moves towards the principal axis. Whenever the light rays are incidenting on the convex mirror, it move diverge. So the light rays will move away from the principal axis. That's why it is called diverging mirror. Diverging. It's actually it is convex mirror. So it is convex mirror. So convex mirror does act as a rear view mirror. Convex mirror act as a rear view mirror. Convex. Tell me, Victor, what you want. So please. So suggestions. Always welcome. So I'll try. Shanoshan. So thank you so much for keep attending and keep following and keep asking. I am very happy to see you in the class. Sir, can you once summarize the electricity? I want to revise for only 5 minutes, please. Okay, done. So after completion of this, okay, this completed. Okay, Sivani, just 5 minutes. I will explain. So fine, no problem. So this converging or diverging. Next we'll go for ray rules. Remember everyone. So Sivani, listen here. So electricity. So first one, electric current, the rate of flow of charge. So sorry for the interruption. So one student asked about electricity. I'm giving the points. So please, sir, why are you wearing the strange dress? Why, sir? Oh, no shame. So be in the class. This topics also helpful. Okay. So be in the class, attend the class. So I'm very happy. Okay. So now you are seeing. This is not a stranger. This is one of the teaching aid. Okay. Come to the Sivani. First point. Rate of flow of charge I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Thank you so much. Thank you so much, Victor. Okay, the next one. So definitely I'll do it. Now we are going to the next topic is rate of flow of charge. SI unit of current is SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So that is one point. And coming to the potential electrical appliances, cell battery. Okay, cell battery, open switch, closed switch, open switch, closed switch. And next one, ammeter, voltmeter, resistor, rheostat. This diagrams. Once you practice the diagrams, Sivani, so very important. Try to practice. Coming to the potential difference. Potential difference in arithmetic work done to bring unit positive charge from one point to another point within the conductor is called potential difference. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. V equal to W by Q. So 1 volt equal to 1 joule by 1 coulomb. V equal to W by Q. 1 volt equal to 1 joule by 1 coulomb. So that is a potential difference. And coming to the next one. Electric circuit. A continuous and closed path of an electric current is nothing but electric circuit. A continuous and closed path of an electric current is known as an electric circuit. Okay. So conventional current and electric current. Conventional current will be taken from positive terminal to negative terminal. Electric current will be taken from negative terminal to positive terminal. Okay. So next one we are going to the Ohm's law. So the potential difference across a given metallic conductor, the potential difference across the given metallic conductor, across the ends of the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. V is directly proportional to V equal to IR. V is directly proportional to V equal to IR. Okay, so that is about Ohm's law at a constant temperature. At a constant temperature, the potential difference across a given metallic conductor, that is nothing but resistor you can take. So it is directly proportional to current flowing through it. V is directly proportional to V equal to IR. So that is nothing but Ohm's law. So physical conditions also we can take constant if they ask in the exam. So you can write. So at constant temperature and physical conditions, so nothing but length, area. So length and area and material, particular material also we can take. Okay. So next one we are going to the one more topic. So we are going to the one more topic. So that is about Ohm's law already completed. Materials required 4 cells and a nichrome wire, ammeter, voltmeter, cell, battery. Okay na? So battery, that's enough. That is about this point. Materials required. Next one, procedure. So first connect one cell and note down the reading of ammeter, voltmeter. Next connect 2 cells, note down the reading of ammeter and voltmeter, and continue the process for 3 and 4 and note down the readings of ammeter and voltmeter and mention in the tabular form. So draw the tabular form. No need to fill the table. Just you can draw the table. So draw the graph for VI. It is linear. So for ohmic conductor it is linear. Non-ohmic conductor it is curve. So that is about ohmic conductor substance, which for the substances, the conductor, the conductors which obey Ohm's law, those are called ohmic conductors. The conductor which does not obey Ohm's law, those are called non-ohmic conductors. So that is completed related to Ohm's law. Coming to the resistors are connected in series combination, resistors connected in parallel combination. So formulas are very important. So especially I is constant in series combination, potential difference is constant in parallel combination. So in series, all you have to add all resistance. In parallel, you have to add all the in parallel we have to take 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that is about series and parallel. Coming to heating effect of electric currents, already the derivation, everything I given. So derivation, everything I given. So follow the derivation. Very important derivation. Very important derivation. And after that example for heating effect of electric current, electrical iron, electrical cooker, electrical oven. Okay, so these are the related to heating effect of electric current. And next one, so we can go for commercial unit of energy is kilowatt hour. Commercial unit of energy is kilowatt hour. 1 kilowatt hour equal to 3.6 into 10 power 6 joule. Resistance and resistivity. So resistance is nothing but the phenomenon of opposing the electric current in the circuit. SI unit of resistance is ohm. So it depends on length and area. So it depends on temperature. It depends on material. Resistance. Resistivity is nothing but resistance of the conductor per unit length and unit cross section area. Resistivity does not depend on physical dimensions. That is nothing but length and area. It depends on temperature. It depends on material of the conductor. That is about resistivity. Resistance and resistivity. I hope it is clear to you. So next one, we are going to the short circuit. The direct contact of live and neutral wire takes place. Then heavy amount of current will be drawn from the mains. So then it is called. What is that? Short circuit. The direct contact of live wire and neutral wire takes place. So then heavy amount of current will be drawn from the mains. Heavy amount of current will be drawn from the mains. So heavy amount of current will be drawn from the mains. So that leads to fire. So it will fire happens in the buildings. And next one more thing, overloading. So high voltage appliances on at a time. So then heavy amount of current will be drawn from the mains. So that is overloading. I hope it is completed. Is it clear, Shivani? So if it is okay means I'll go. If you have any doubts, you can ask. So 5 minutes. I don't know how much time it took. Okay, so thank you so much. V is equal to IR. Yeah, Ohm's law. Mahesh, Arya. Yes, Mahesh. Wow. So I hope within 5 minutes I completed. So maybe. So I don't know. Fuse is used for Sir, it is a safety device. So it is a safety device for protecting the appliances when a heavy amount of current. So extra amount, as it is fixed one certain amount only it will allow. So more than required limit it will goes. So current will flow through the circuit. It melt and breaks the circuit. That is about fuse. And coming to the earthing. So extra current is there in the circuit that will pass to the ground. So like example, if you see the computers, now I will go to numericals. Thank you. Thank you, Shivani, Sam. So be all the best. All the best. So definitely your work will show in exam. You will do great. So definitely you will do in rock. You will do rock in exam. So can current flow in a circuit without voltage? So without connecting battery, how it will go? That is only voltage. So by connecting the battery only, it will go. Can you explain Kirkas? Boss. So definitely, boss, I'll take time and explain. Right now, so till now I explained electricity. Actually, I deviated from the topic. So for student tomorrow exam is there. That's why I explained. So let me surely I'll explain. First, we'll go to the next topic. Okay, Kirchhoff's laws, only two laws are there, junction law and loop law, boss. So I will tell simply. So as you asked, morning also you asked, that's why I'm telling. Junction law and loop law. Junction law is nothing but, so some of the current leaving. So some of what of the current is moving towards the junction equal to what of the current is moving away from the junction. That is junction law. Loop law. So there is many points are there. So there are 4 points are there. 4 points are there. Those 4 points are so according to the battery and according to the resistor and according to the current direction. So 3 points related to 3 points will take, boss. So I don't know your name. So you asked about loop law. So I'll explain. First, coming to the battery, if we are going to the positive to negative, it will be negative. So opposite to the current, it is positive, like that. So it will be little lengthy. So we have to explain with examples. So I'll try, boss. I'll try. Okay. Definitely. Sir, is there any point in rotating wheel or vehicle at rest? So thank you so much. Okay, so okay, boss. Definitely, I'll do it. Now come to the point: concave mirror and converging mirror. So concave mirror is also known as converging mirror. So convex mirror is also known as diverging mirror. So next one we are going to the next one. So ray rules of concave mirror, ray rules of concave mirror, ray rules of concave mirror. So I'm taking the concave mirror, concave mirror. So I'm taking the concave mirror. So only 4 ray rules are there. So if you are going to war, you need weapons. Yes or no? Sir, थोड़ा हिंदी में ज़्यादा इंग्लिश में नहीं आता. CEO ने are you? I'm sorry for that. Right now, I am extremely sorry from my bottom of heart. So I am very sorry for that. Definitely, I will try. So I will. So I can say proudly, I'm a little bit fast learner. Little bit fast learner, not too much. So little bit fast learner. Definitely, I will learn. So very soon. Okay. So definitely, I will learn. So definitely, I will teach. So within soon you will see my this face you remember. In this face will speak in Hindi. Okay, definitely will speak. So thank you so much for supporting us. Until then, please do like, share and subscribe and inform your friends, ask them to join to the class. So please type in English. So definitely see, if you type in English, I can respond to your question. Yes, sir. Oh my God. Thank you. Okay, Victor. Definitely. Actually, no. Victor, actually, this concept, whatever I thought, that is for one student. So she asked me to explain briefly, like summarizing. That's the reason so with the flow, I explained. So definitely, Victor, I will explain to you only. Derivative of, okay. Okay. Come on. So if you like this video, do like, share, and subscribe to Student in the Brand. This is your Siva sir. This is the Student in the Brand, my channel. So if you like this content, please do like, share, and subscribe to Student in the Brand. So you can inform to your friends, ask your friends to join to the class. Extraordinary content, marvelous content, mind-blowing content. Definitely you'll get it. You won't regret. By joining the class, you won't regret, definitely. So you'll get content. Okay, so come to the class and join. Can you learn lens form? Yeah, lens formula. Okay, so on by sorry, you will grow big. I'm sure I will support. Thank you so much. Explain advanced sir gas by. So okay, Nashin. So all the best. Definitely tomorrow I'll try. So at 6 p.m. So tomorrow 6 p.m. you can join to the class. So live class you can join. I'll teach motion in a straight line. Okay. So actually I'm planning to do. Already I did two topics like units and measurements and scalars and vector. These two topics I explained. So I'm going to explain about motion in a straight line. So no notion. So you join it tomorrow. So 6 p.m. class you join. Definitely I will teach motion in a straight line. So keep these words. So join to the class. Okay. So 6 p.m. Sir, can you teach by? I am very sorry. So eating, drinking, sleeping, walking, moving, anything, physics only, because so I'm very interested, very much interested in physics. So that's why I'm teaching physics. So can you explain rotatory motion? Okay, okay, Shank. So rotatory motion easy, boss. That is so whatever we are taking the linear motion, that we are converting in the circular motion. We are converting the circular motion. Angular quantities will be added. Angular quantities will be added. So angular displacement, angular velocity, angular speed, angular velocity, angular acceleration. So omega. So there we are taking yes. There theta omega 1 omega 2 and so alpha is nothing but acceleration. So these quantities as it is we are converting into angular quantity. That's enough. Here we are talking, sir, one physics, then answer my question. What is your question, Nikhil, please? So with my knowledge, with my best, okay, regards I can answer. So if you ask beyond my knowledge, so I will try to learn and answer. I'll try to learn the concept and answer to your question. Victor, rotator motion you asked, right? Okay, boss, I'll do it. Okay. So right now I am living in Hyderabad. Okay. So you can, if you want any regarding the classes, if you want any doubts. So if you want any doubts, you can call to this number 9849812804. This is the number you can call. You can message. What happens to the? So boss, it depends. P equal to 1 by F. P equal to 1 by F. Okay. 1 by F you are taking 1 by B plus 1 by U. So okay, that is concept. Definitely I'll explain. So if you want more details, you can contact to this number. So if you want more details regarding anything, classes or anything you want, you can contact to this number. Okay. So let me finish the concept because concept it is pending. So coming to the ray rules, first one ray rules. I'm taking pole, focus and center curvature. Pole, focus and center curvature. Pole. So focus and center of curvature. One light ray I'm taking like this. After reflection, it passes through the focus. One light ray is incidenting on the mirror. It reflects back. It passes through the focus. Second light ray I'm taking. If you're taking here, so I'm considering like this: pole, focus. This is the pole, focus, and center of curvature. So after see one more light ray. One more. So this is a convex mirror. Convex mirror also, if the light ray is coming after reflection, so I'm taking one side is concave mirror, this is a concave mirror, and this one is a convex mirror, this side is concave mirror, this side is convex mirror. So after incident it passes through the focus. Here after incidenting it passes through the focus if you are extending this one. Second one, if you are taking if you are considering here, so this is the pole, focus and center curvature. Pole, focus and center curvature. If the light ray passing through the focus, after reflection passes towards infinity. So here also second one, if the light ray is passing through the pole, focus and center of curvature, if the light ray passing through the focus, after reflection passes towards infinity. And third one, at the light ray. So I'm taking here pole, focus, center of curvature. If the light ray incident at the pole, it reflect back. So here also same thing in convex mirror. In convex mirror, pole, focus, center of curvature. If the light ray incident at the pole, it reflect back. So it reflect back. And fourth one is very very important. Fourth one is very very important. Fourth line, yeah, very important. So here I'm considering like this. Okay, so fourth one you are taking. Fourth one I am considering here. I am considering here pole, focus, and center of curvature. If the light ray passes through curvature, it reflect back. And so for convex mirror also, if you are taking here pole, focus, and center of curvature, if the light ray incident at the pole, it reflect back, so you are passing through the center of curvature. Okay, so if the light ray incident at the incident on the mirror, it passes. If it is passes through the focus, after reflection passes towards infinity. If it incident at the pole, it reflect back. So here, if the light ray passing through center curvature, it reflect back, it passes through the back. So it retraces its original path here also. If it is passing through center curvature, it retraces its original path. So these are the ray rules. These are the ray rules of concave mirror and convex mirror. Concave mirror and convex mirror. So diagrams, how to draw the diagram, how to take, how we have to mention, how the ray rules are there. I hope I did one video. I did one video each and every time. If you are drawing, it will take nearly one diagram. I explained 1 hour. So one diagram I explained 1 hour. 1 hour regarding the points. So one diagram I explained 1 hour. Nearly only one diagram. So points, lines, everything I explained. Everything I explained. Okay. So everything I explained. So once you can check the video, I will take how to draw the diagram also. I will take one class. I will take one class. That time we can see. Okay, na? So meanwhile, you are going to the terms related to spherical mirror. Terms related to spherical mirror. Terms related to related to related to spherical mirror. Terms related to spherical mirror. Terms related to spherical mirror. What are the terms? Are nomenclature. Terms are nomenclature. Terms are nomenclature. Terms are nomenclature. So terms related to spherical mirror. So power of lens is nothing but reciprocal of focal length. So P equal to 1 by F. P equal to 1 by F. P equal to 1 by F. Reciprocal of focal length. Or the degree of converging or diverging of lens achieved is known as power of lens. Power of lens. Okay. Class 12, yes, definitely. Okay, so next we'll go to the next one. If you like this video, please do like, share, and subscribe to Student the Brand. So this is Siva sir. So you can share to your friends also. Here I'm considering, I'm taking here. So this is a part of the sphere. This is a part of the sphere I'm taking. This is the center of the imaginary sphere. So actually, this is the part. Normally, if you are taking the sphere, we are taking small curvature. This is a curvature. This is the curvature, small curvature. So normally, if you take it is a part of the sphere. So this is the center of the sphere. So center of the imaginary sphere in which mirror is a part. So if you are taking like here, class 11, it is happening 6 p.m. every day. So tomorrow onwards, motion in a straight line, I will explain tomorrow evening 6 p.m. So you can join Meena Verma. So you can join at 6 p.m. Tomorrow class for class 11. So center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part, that is called center of curvature. So the midpoint of the mirror is called pole. The midpoint of the mirror is called pole. So the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. So violet, boss, you'll get violet. Nickel, violet. Violet, indigo, blue, green, yellow, orange, red. Vibgea, the format. Violet, indigo, blue, green, orange, red. So class 12. So class 12, actually this is related to class 12 topics only. So I'm explaining. I will plan separate classes for class 12. Class 12. So class 11, you can go and tomorrow 6 p.m. Class 11. Class 12, definitely. So we are working on evening time only. I will let you know exactly at what time. So this class will helpful for class 12 students also. You can join and attend the class. You can join and attend the class. So especially for class students, I will take the classes. I will let you know soon. So class 11 timing fixed 6 p.m. evening. Class 10 this time 9 p.m. and class 12 I will let you know. Class 12 I will let you know. We will see. Okay na. So now we are considering. So the distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. The distance between central curvature to pole is called radius of curvature. So distance between central curvature to pole is called radius of curvature. So after reflection, all light rays will meet at one point. After reflection, all light rays will meet at one point. That is called after reflection, all light rays will meet at one point. So their image will form. So that point is called focus. After reflection, all light rays will meet at one point. So their image will form. So that is called after reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. After reflection, all light rays will meet at one point on the principal axis. That is called focus. This is also called, normally it is called principal focus. It is called principal focus. Okay, boss. So whatever you say, so I'll see. So I'll explain later. First we'll go to the next one. So after reflection, the light rays will meet at one point on the principal axis. That is called focus. The distance between focus to pole is called a focal length. The distance between focus to pole is called focal length. The distance between focus to pole is called focal length. Once Nikhil, read the question what you typed. Okay, so in the message. So then accordingly you say. So once read the question, whatever you type, let me know. After that we will discuss. Okay. So it's fine. Just one check. So it's my request. Just check once. So here you can take the distance between focus to pole. The distance between focus to pole. Distance between focus to pole. Distance between focus to pole is called focal length. Distance between focus to pole is called focal length. The distance between central curvature to pole. Distance between central curvature to pole is called. Distance between central curvature to pole is called. Okay na. So the distance between central curvature to pole is called radius of curvature. The distance between focus to pole is called focal length. Distance between central curvature to pole is called radius of curvature. Distance between pole is called focal length. Okay. So these are the points. This is very important. Very important. So what are the points we are discussing? First one is central curvature. Second one is pole. Third one is central curvature, pole, focus. And fourth one, the line joining of central curvature and pole. The line joining of central curvature and pole. The line of central curvature and pole. The line joining of central curvature and pole. The line joining of central curvature and pole is called. The line joining of central curvature and pole is called. The line joining of central curvature and pole is called the radius, like a principal axis. The line joining of central curvature pole is called principal axis. The line joining of central curvature and pole is called principal axis. Next one, we are going to the next point. So fifth one I am considering. So central curvature, center of the imaginary sphere in which mirror is a part. Pole is the midpoint of the mirror. Focus is the after reflection all light rays will meet at one point. After reflection all light rays will meet at one point. That is called principal focus or focus. So the line joining of central curvature and pole is called principal axis. The line joining of central curvature and pole is called principal axis. The width of the mirror is called aperture. Width of the mirror is called aperture. Width of the mirror is called aperture. So focal length, 6 1 is focal length. The distance between focus to pole, that is called focal length. So these are the 6 points. Once again you can check: center of curvature, pole, focus, radius of curvature also there. Seventh one, radius of curvature. So these are 7 points. Radius of curvature means the distance between center of curvature and pole. 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 Distance between center of curvature and pole is called radius of curvature, and distance between focus to pole is called focal length. Width of the mirror is called aperture. The line joining of center of curvature and pole is called principal axis. Center of the imaginary sphere in which mirror is a part is called center of curvature. So P is the midpoint of the mirror, that is called pole. So after reflection all light rays will meet at one point. After reflection all light rays will meet at one point. After reflection all light rays will meet at one point on the principal axis, that is called principal focus, or simply called focus. Okay na? So 5 minutes break. 5 minutes break I am for me. For me, at the same time for you also. 5 minutes you can take break. After that I will discuss about image formations. Image formations. Image formations. Image formation by concave mirror. Image formations. Image formations by concave and convex. Concave mirror and convex mirror. Convex mirror. Convex mirror now. So I'll resume the class 10 10:30 or 10 10:30 I'll resume 10:30 p.m. So Okay, done. Come to the point. So we are starting again. So image formations. Image formations. Be ready. Concave mirror and convex mirror. Concave mirror and convex mirror. So welcome to the class. Concave mirror and convex mirror. Concave mirror and convex mirror image formations. Image formations. So concave mirror image formations. Concave mirror. If the object is at infinity, so if the object is at infinity, so I'm considering now. You can see. So first one. So this is a concave mirror. This is a concave mirror I'm taking here. This is a concave mirror. So here is the object. Here is the object. So I'm taking the pole, focus, and center of curvature. Object is at infinity. Object is at infinity. So how many light rays are required to form the image of the object? Minimum 2 light rays. Minimum 2 light rays are required. So I'm taking one light ray like this. After reflection passes through focus, another light ray I'm taking. After reflection passes through focus. Okay, object at infinity, image will form at focus. Object is at infinity, image will form at focus. So nature of the image is real and inverted. Nature of the image is real and inverted. And coming to the size of the image is highly diminished. Size of the image is highly diminished. Highly diminished. Coming to the second one, coming taking here. So if you are taking object is here. So pole, focus, center of curvature. Object is placed beyond center of curvature. One light I am taking. So after that it passes through focus. Another light I am taking, it passes through center of curvature. So if you are taking like this, so here the image will form between C and F. Object between beyond C, image will form between C and F. Nature of the image is real and inverted. Size of the image is diminished. Compared to the object, image size is decreased. Coming to the third one, if you are taking here, if you are considering here, so this is the pole, focus, center of curvature. Object is placed at center of curvature, image will form at center of curvature. One light I am taking like this, it passes through focus. Another light it will meet at pole, so it reflect back and meet at C. Okay, so object at C, image also will form at C. Nature of the image is real and inverted, and size of the image is same size. Either size of the image is same size. Okay, so object at C, image also will form at C. So nature of the image is so real inverted, and size of the image is same size. Very, very important point. So keep this one in mind. Once again, object is at infinity, image will form at focus. Nature of the image is real and inverted, and the size of the image is highly diminished. Once again, object is placed beyond center of curvature, so image will form between C and F. So nature of the image is real and inverted and diminished. So object is at C, image will form at C. So nature of the image is real and inverted. Size of the image is same size. Okay. So this is about image formations. Next one we are talking about next image formation. So if you are taking the concave mirror, so fourth one, this is the pole, focus, center of curvature. Object is placed between C and F. One light ray taking like this, it passes through focus. Another light ray, it will incident at the pole, it reflect back. So the image will form between here. So sorry, the image will form beyond center curvature. Object is placed between C and F. Image will form beyond C. Nature of the image is real inverted, and inverted. Size of the image is enlarged. Size of the image is, yes, compared to the object, image size is increased. Compared to the object, image size is increased. So next one, fifth one. Fifth one, I am taking like this. So this is the pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at F. One light I am taking like this, it passes through focus. Another light pointing at the pole, it reflect back. So object at F, image will form at infinity. Nature of the image is real and inverted and highly enlarged. Real and inverted and highly enlarged. Real and inverted, highly enlarged. Highly enlarged. Coming to the sixth one. Sixth one is very important. Sixth one is very important. Pole, focus, center of curvature. Pole, focus and center of curvature. Object is placed between F and P. Object is placed. This is very important. 3 marks question. Definitely 3 marks question will come. Definitely 3 marks question. That much important. So object is placed between F and P. Object is placed between F and P. Very important. Very important. Very important. Come on. Be active. Still the time is 10:36. Our Josh and energy will not decrease. Object is placed between F and P. Image will form behind the mirror. Nature of the image. Virtual, erect, and enlarge. Very important. So here you can see. Object is placed between F and P. Image will form behind the mirror. So one light I am taking here. So it passes through focus. Another light I am taking through a pole. It reflect back. So if you are extending those light rays, so the image will form behind the mirror. Image will form behind the mirror. Nature of the mirror is virtual, erect and enlarge. 3 marks question, very important. For 3 marks question, very important. Make sure that you are practicing this question. Very important for 3 marks question. Come on for 3 marks question. New Cartesian sign convention. All distance measured from the pole. Distance positive along the instant. Distance negative opposite to instant. Distance positive above the principal axis. Distance negative below the principal axis. Okay, done. Come to the point. Next one, we are going to the next one. Okay, so until here, related to toxic in high. So until here related to concave mirror. Next one we are going to the convex mirror. Convex mirror, only 2 image formations are there. Convex mirror, only 2 image formations. Now we will see. Convex mirror, only 2 image formations. Convex mirror, only 2 formations. So I am from Hyderabad right now. So convex mirror. So very important concept I will say. So convex mirror. So it forms always virtual, erect and diminished image. Only one mirror. So we will tap for a convex mirror. Very important mirror. So very important. I'm tapping for a convex mirror because convex mirror forms always virtual, erect and diminished image. So So you can contact to this number 984981280. You can contact to this number. So we'll discuss more points. Okay. So come to the next one. Next one. Convex mirror forms always virtual erect and diminished image. Even if you place in front of Taj Mahal also, we can get a full view of Taj Mahal. That much that much important it is. If you place in front of Taj Mahal, we can get full view of Taj Mahal. So any object if you place in front of this mirror, will get a full size of the image. So that is the power of convex mirror. Convex mirror always forms virtual erect and diminished image. Convex mirror always forms virtual erect and diminished image. Now we will draw the image formations. I am taking the convex mirror like this. So this is a pole, focus, center of curvature. So I am taking this one light ray, another light I am taking. After reflection, those light rays will move. So if you are extending those light rays, the image will form at focus. Object at infinity, image will form at F. Nature of the image is virtual erect and diminished. Diminished image, highly diminished. So it's not diminished, highly diminished. Very, very important, highly diminished. Second case. So pole, focus, center of curvature. So object is placed anywhere between infinity and pole. One light I am taking like this, another light I am taking like this. So it will be reflected. So if you are extending this one, it will passes through the focus. So image will form here between P and F. So object is placed at between P and infinity. Image will form between P and F. Nature of the image is virtual erect and diminished. Virtual erect and diminished. So those who want any classes regarding any concerns, any doubts, you can contact to this number 984981280. This is the number. So you can contact to that number any classes, any suggestions, any doubts regarding physics. You can contact to that number. You can check. So right, that's enough for convex mirror. So next one, sign conventions. So sign conventions are very, very important. So now I'm discussing the sign conventions. Concave mirror I'm taking, concave mirror I'm considering. Here is the pole. So pole, focus, center of curvature. All measurement will be taken from the pole in the direction of incident rays. Distance, image distance, focal length, all are positive. Opposite incident rays, object distance, image distance, focal length and radius of curvature, all are negative. Above the principal axis, height of the image and height of the object positive. Below the principal axis, height of the image and height of the object both are negative. Simply as we can say, coordinate axis you know, right? So x-axis and y-axis, all measurement will be taken from the optic center. Positive x-axis, negative x-axis, positive y-axis, negative y-axis. Same thing along in the direction of incident rays, all are positive. Opposite incident all are negative. Above the principal axis positive, below the principal axis negative. So now I will sing all these points in the format of song. Listen carefully. New Cartesian sign convention. All distance measure from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention, new Cartesian, sign convention, all distance measure from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So I hope you like it. So if you like this video, if you like this song, please click on like button, and so please do like, share and subscribe to Student Brand. If you like this content, you can inform to your friends, ask them to join to the class. So this is about sign convention. All distance are measured from the pole. In the direction of incident is positive, opposite to incident is negative, above the principal axis positive, below the principal axis negative. Simple, 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 simple. Easy, 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 easy. Come on, come on, come on. Very, 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 very simple. Okay, so I hope it is very clear. So now we are going to the next one, mirror formula and magnification. Mirror formula and magnification. Mirror formula and magnification. So mirror formula 1 by f equal to 1 by v. So mirror formula 1 by f equal to 1 by v plus 1 by u. Mirror formula 1 by f equal to 1 by v plus 1 by u. And magnification equal to, so height of the image by height of the object, that is nothing but minus v by u. So height of the image by height of the object, height of the image by height of the object, m equal to minus v by u. So 1 by f equal to 1 by v plus 1 by u. Okay na? So this is about mirror formula and magnification. Next one, so we are going to discuss about lens. Lens will discuss in tomorrow class. So you can join to the class. You can join to the class. If you like this video, please do like, share and subscribe to Student the Brand. Repeat karo sir. Wow, you want a song to repeat? Okay, so I'll sing for you. So I'll sing. So Meena Verma, I'll sing for you. New Cartesian sign convention. New Cartesian sign convention. All distance measured from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal axis. Distance negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. All distance measure from the pole. Thank you so much. So this is our Shiva sir from Student Brand. If you like this content, do like, share and subscribe to Student Brand. So click on like button. Click on like button if you like this content. If you like this video, and share to your friends and ask your friends to join to the class. So let them learn, and so everyone can learn physics. Okay, in easy way. So simple. You can join and ask if you have any doubts. If you need any clarification regarding the classes, you can contact this number 984981280. So do like, share and subscribe to Student the Brand. So this is Shiva sir signing off. Thank you. So next topic we'll discuss in the next class.